Question 33. The table shows the number of carbon atoms present in the molecules in 4 of the fractions of petroleum. 1 mole of a compound in fraction F is completely burnt in excess oxygen. The reaction produces 17 mole of water. Assuming the compound in fraction F is saturated, what would be a use for this fraction? So fraction F could be naphtha, paraffin, lubricating oil, or the bitumen fraction, which is unknown to us. Fraction F, however, contains the compound which is saturated, which means it will be an alkane and not an alkene. Saturation refers to the presence of only single bonds between the carbon atoms in the organic molecule. Let's write the equation for the compound, the alkane compound, and oxygen. Since we do not know the specific number of carbon and hydrogen in the alkane, we can leave it as the general formula. And burning in excess oxygen refers to complete combustion that should only give us products of carbon dioxide and water. It says that 1 mole of this compound burned in excess oxygen gave 17 moles of water. 17 moles of water. They didn't tell us the number of moles of carbon dioxide gas, so let's leave that as an unknown. Since oxygen is in excess, there is no need to be concerned about how much oxygen was actually reacted, because the amount of water and carbon dioxide produced will depend on the limiting reagent, which will be the organic compound in this case. Since 17 moles of water is produced, we can conclude that there are 17 times 2 number of hydrogen atoms in the products. Water is the only product that contains hydrogen atoms. So it is safe to assume that all of these hydrogen came from all of the hydrogen in the organic compound. So if 2n plus 2 number of hydrogen in one molecule of this compound gave 34 number of hydrogen atoms, n will be 16. Therefore, we can derive the molecular formula of the compound to be C16H34 by substituting the n equals 16 into the general formula. Having 16 carbon atoms, the compound will fall under the paraffin fraction, and a use of the paraffin fraction will be as fuel for aircraft engine. A source of polishes and waxes will be the use for lubricating oil. Feedstock for other organic reactions will be the use of the naphtha fraction, and lastly, bitumen will be used as the fraction to make road surfaces.